Greetings and welcome back to EDUC 771, Analyzing Educational Research Week 1.
Week 1 assignments, as indicated on the syllabus, include reading from Chapter 1 and Chapter 3. We will return to Chapter 2 next week. Review Week 1 PowerPoint slides and Blackboard inside the Assignments tab. Complete Chapter 1 review problems. They are worth 5 points. You can locate the review problems in Blackboard inside the Assignments tab. Chapter 1 review problems are due on September the 13th. Complete Chapter 1 activity. You can locate this activity in Blackboard inside the Assignments tab. Remember, these activities are great practice problems for your upcoming quiz. Complete Chapter 1 reflection. You can locate the reflection in Blackboard inside the Discussion tab. This assignment is due on September the 13th.
This week we will cover Chapter 1, Science, Schooling, and Educational Research, pages 3 to 19 in the textbook. This chapter will provide insight on how to avoid errors in educational research and discuss educational research approaches. Chapter 1 answers the questions: what is scientific about educational research? And what motivates selection of a research question or focus? We will also cover in Chapter 1 the distinction between quantitative and qualitative research while describing 4 types of educational research and their relation to goals and methodologies. Finally, we will cover the similarities and differences of various educational research philosophies. Educational research is complex. It involves learning about the educational world by asking many questions, obtaining information from many sources, having criteria for evaluating various answers, and determining methods for seeking your answers. It also involves analytical thinking. Educational research, as we know, relies on analytical thinking. So let's examine a few errors in thinking or reasoning that will help us mitigate, reduce, or lessen the likelihood of this occurring in our own research. We will utilize some examples I made up, but primarily from the text based on the letter written from Ann Landers and her cats, which are located in the text on page 6. The first error in reasoning or thinking is inaccurate observation. This is based on faulty perception or empirical reality. An example of this may happen in the classroom, where I might say I noticed 5 students arrived late to class, but in actuality, only 3 students came in late, as my perception of how many students arrived tardy to class was completely skewed. The next error in thinking or reasoning occurs in selective observation, which is choosing to look only at things that are in line with our preferences or beliefs. So for example, Anne observed her cats at the outside door once and came to the conclusion that even when given the opportunity, cats didn't really want to play outside. Another example is overgeneralization. Overgeneralization occurs when we assume that what is true for 1 or 2 cases are true for all cases. So we draw conclusions from our experiences, but our experiences are limited. For example, if I caught 1 student in a group cheating, is it correct to assume all students in the group were cheating? Well, in Anne's example, She observed the behavior of two cats and drew a conclusion about cats in general. Illogical reasoning, another form of error, occurs when we prematurely jump to conclusions or argue on the basis of invalid assumptions. For example, Anne assumed others feel guilty about keeping their cats inside, and cats are motivated by feelings about opportunities to play. Finally, we have resistance to change. In Anne's example, she had no need to change her approach to her thinking regarding her cats. Resistance to change usually occurs due to ego-based commitments or excessive devotion to tradition. Chapter 1 Reflection. Feel free to share your thoughts in the discussion board to the following. As a teacher, think about a time in your classroom when you have overgeneralized or exhibited selective or inaccurate observation, illogical reasoning, and or resistance to change. Now think about classroom procedures, rules, or expectations you've implemented to reduce or avoid errors in your thinking. In order to reduce the potential sources of error in reasoning, educational research builds on the methods of science, whereas science is a set of logical, systematic, documented methods for investigating nature and natural processes.
In educational research, we employ approaches that reduce the likelihood of overgeneralization by using systematic procedures, avoid illogical reasoning by using explicit criteria for identifying cause and determining whether these criteria are met, and by reducing the risk of selective or inaccurate observation by measuring and sampling phenomena systematically.
Research initially begins with a question. Researchers may formulate a question based on various motives. One motive for asking a particular question is the researcher's own life, experience, and values. For example, a researcher may be interested in studying mathematics education in primary or secondary education because of his or her own experiences in mathematics as either a student, teacher, or based on their siblings or children's own experiences. Academics is another motive for a researcher to gain better understanding of educational processes. For example, a mathematical researcher may want to understand the impact of supplemental support such as tutoring outside of school and its impact on student achievement in mathematics. Therefore, this researcher may ask, does supplemental interventions in mathematics such as tutoring build students' confidence and academic achievement in mathematics? A question such as this may motivate a researcher to better understand the implications of supplemental education in mathematics. The final motive for educational research we will discuss is policy. A researcher may ask a particular question in order to provide information to local, state, or federal agencies interested in implementing programs or policies. For example, a school district may seek to better understand the effects of cooperative learning in mathematics so they can embed such approaches into their school's curriculum.